I'm Andrew Hopkins. I work at the Australian Astronomical Observatory. I'm the head of AAT Science here at the AAO, the AAT being the Anglo-Australian Telescope. I did my undergraduate work and my PhD at the University of Sydney. I spent 6 years following that working in the US at the University of Pittsburgh. I was fortunate enough to receive a Hubble Fellowship during my time there. And then I came back to Australia in 2005 to take up a research position again at the University of Sydney, before moving here to the Australian Astronomical Observatory in 2008. I'm actually involved in a variety of different research projects. I'm involved in projects making heavy use of the Anglo-Australian Telescope, in particular a project called GAMMA, which stands for Galaxy and Mass Assembly. I'm also involved in projects upcoming with the Australian SKA Pathfinder, the radio telescope currently being built in Western Australia. The project that I'm very heavily involved with on that front is called EMU, and EMU itself stands for the Evolutionary Map of the Universe. So you can see that we like our acronyms. EMU will do observations of the entire hemisphere with ASCAP at radio continuum wavelengths, looking for the radio emission coming both from the supermassive black holes in the centres of galaxies, as well as from the star formation in galaxies, and how those two things change over the history of the universe. The Gamma survey is aimed at looking at the redshifts and physical properties of galaxies out to relatively nearby distances, probably corresponding to the last 4 or 5 billion years of the history of the universe. And in fact, these two surveys themselves are quite complementary, both looking at how galaxies are forming and evolving in different ways. I'm involved in a variety of other projects. The SAMI project, which is making use of a new technology that's been developed both here at the AAO and also at the University of Sydney, is a project which uses a technology called integral field spectroscopy. It measures spectra, not just one spectrum per galaxy, but spatially resolved over the individual galaxy images, so that you get information about how the physical properties within the galaxies are distributed. SAMI will be used to map a few thousand galaxies in this way, and we'll learn from that a lot about how the star formation is distributed throughout the galaxies, how the dust is distributed throughout the galaxies, what other physical processes are happening, winds and outflows, ionization from the energetic supermassive black hole in their cores, if they have one, and how all of these things depend on the age of the galaxies and how they're distributed in relation to other galaxies in their immediate vicinity, their local environment. I think astronomy is an absolutely fascinating career, understanding how a system as large as a galaxy, the Milky Way that we live in, can actually have come together over 13.5 billion years of cosmic history is just mind-blowing. Being able to make observations with the most advanced telescopes in the world is an immense privilege, and it's something that is incredibly rewarding. I think that being able to identify the answers to some of the most fundamental puzzles in the universe is both a challenge, but when you find that it's something that you can do, it's incredibly rewarding. And so I think that working in astronomy is absolutely fantastic, and I would certainly encourage it.